This is just a short follow-on video from my previous video about bidirectional control of a DC motor. I'm just going to show how to add an additional wire to facilitate speed control if you wanted to vary the speed that the motor is turning at by adjusting the amount of power that we're delivering to it. So the extra wire that I've added here is connected to one of the previously unused corner pins on the chip. In this case it's pin 9, and this is what they call the enable pin for the two channels on that side of the chip. So I'm using channels 3 and 4 on the SN754410, and both of those channels, normally the outputs are controlled by the signals feeding in from the Arduino, but we can override the outputs by feeding another signal into pin 9, and it's able, if you set that input low, then it makes sure that the two outputs are temporarily pulled low irrespective of what the other two signals are telling it to do from the Arduino. So the basic idea is we're going to feed in a train of pulses in this enable pin here, and it means that instead of getting a solid continuous output at either high or low, we're going to get out a sort of a pulsed output when the inputs are high. When the inputs are low, we'll still just get nothing out. So we'll still be able to control the direction of the motor in the same way as before and switch the motor on and off as before. But the pulses that we feed in here will control how much power is delivered to the motor when it is switched on. So we'll just look briefly at the data sheet here first to see where that pin is. So if I scroll back down to the pin out here and we zoom in a bit, you can see that the enable pin there for channels 3 and 4 is pin 9, so that's the one that I've connected the wire to. Down here in the description it says name is channels 3 and 4 enable, so it's 34N, N is short for enable, and it's the enable driver channels for 3 and 4. So when you don't connect it, it has no effect. It floats high itself, so the pins are enabled if you don't connect anything to it. But if you connect a signal in here, then when the signal you feed in is low, the output of the two channels will also switch low, no matter what the two inputs are doing. Now the pulse signal that we want to feed in here, we need a way to generate that on the Arduino, and there's actually a very easy way to do that. The Arduino libraries provide a function called analog write, and it allows us to generate a continuous stream of pulses on one of a number of pins. It doesn't work on every pin. There's a good few digital output pins on the Arduino Nano, but only some of them are capable of generating these pulsed signals. It's what we call a pulse width modulated signal, or PWM. So you can see that mentioned there. And here's a list on the documentation that is provided with the Arduino libraries for the function analog write. There's a list of which pins work for analog write for each of the different types of Arduinos. So the Nano is in the first list, or first row of the table here, and you can see the pins D3, D5, D6, D9, D10 and D11 are all usable. We're already using pins D3 and D4 to control the direction of the motor, so I've just selected to use D6 for this example as the speed control pin. So I'm going to generate a stream of pulses on pin 6. So on my circuit I've connected D6 with this brown wire here. I've connected pin D6 to my enable pin over here, which is pin 9 on the chip. You can see it's on the same side as the two driver channels that we're using. So that's where the connection is. Let's have a look at what the code is going to look like. Well, you need to enable the pin that you're going to use as an analog output or as a PWM output. You need to enable that first for output. So I've added a line into my setup function here to configure that pin as an output. So that's pin mode 6 output. So this is my PWM channel. So enable PWM output pin. That's going to be D6. And initially in my program here I just have D3 and D4 set low. So at the moment the motor is doing nothing, even though the power is actually switched on here. But let's change this so that it's actually going to switch one of the pins high and one of them low, which means that the motor should be turning. So we can test that first. Now you see there's nothing happening there because at the moment we haven't set the output on our PWM pin to be high, so by default it's just going to be continuously low, which means that the output of the two channels on that side of the chip is currently disabled. So I need to add in a line here to actually switch on pulses on pin D6, and the way we do that is using the analog write function. Specify which pin we want to output the pulses on, so it's pin 6. And you can put in a number here anywhere between 0 and 255, and that will give you pulses of different lengths. So the frequency of the pulses is going to be fixed. I think it's about 500 pulses per second, and that's fixed. But what you can vary is how wide or how long the duration of each of the pulses is. If you set it to 255, the pulses are long enough that the signal is just continuously high, and if you set it to 0, the signal is continuously low. But let's put it to something in between. So I'll set it to halfway between the minimum and the maximum, which is roughly 127. So I'm going to upload this, and what I'm hoping we'll see is that the motor will turn, but it'll turn kind of slowly, and you can see that it is turning a bit more slowly than before. If I was to change the program here to increase the width of those pulses, which means that on average we'll be delivering more power to the motor, so I'm going to increase it to the maximum here and reprogram the Arduino. You can see now that the motor is turning a good bit more vigorously. So let's try and do a bit of a sequence here. So I'll say motor forward, let's say fast for 2 seconds. And then let's say motor forward slow for 2 seconds. Well, let's say for 3 seconds. So this time I'm going to change the pulse width to be half of the maximum. And I suppose let's put in a third part to the sequence here. So we'll just say, sorry, that one there is still motor forward. Let's say motor stop for 4 seconds. So we can still control the direction of the motor just as we did before. And in this case it doesn't matter what pulses we're sending in because the motor is going to be off anyway. Sorry, that delay there should be 4,000. Should be 3,000. And let's switch the LED off for this part as well. Now I'm missing a semicolon somewhere. Here it is. Okay, so let's upload this. So you can see forward fast for 2 seconds, then forward slow for 3 seconds, and then it should stop for 4. And it repeats because these instructions are in the loop function. That's just going to repeat indefinitely. Okay, that's it.